Really, what I saw is that you gotta use like to align them. You don't actually need the p value is more like this is seek, which will be just critical, and you tend to start your chart, right? Oh fuck, you tend to start your chart like your upper one, where you wanna calculate the beta and the power. um, for example, here you see the alignment here, like you see the alignment here in like you see like
Uh,
my mouse. So this is like the part where you will like start
yeah.
it.
So you're getting so.
No. But then you like calculate what? This
So,
operator chart is not good yet. It's not good. Like this one is not good. When you
so,
calculate the beta,
so how
uh-huh.
many how many t values is the center of the upper chart away from the center of the bottom chart?
uh, wait, you're good enough. Say it again.
How many t values is the upper chart away from the center of the upper chart away from the center of the bottom chart?
Uh, this one is not like the chart. I haven't placed the right one yet. That's what I'm trying to tell you. And
So can you tell me? Do you know
like
approximately?
how many approximately?
Yeah, t values is the center of
Yeah.
the upper chart away from the center of the bottom chart.
Uh,
Like eyeballing it,
I
or
bought
like
it.
guessing.
For,
Huh?
but like these values are incorrect. But it will be approximately. Let me check. From this one to the like, but it will not make sense. This one, like these values are just incorrect. So I cannot really give you a real fucking approximate because these
Okay,
charts do
okay,
not make
okay,
sense.
okay, fine. Okay, fine. Okay, I don't know if I interrupted you. Where were you?
Okay, okay. So basically, okay, this chart, you mean like the upper one, like straight up, that makes no fucking sense. Okay, and then you align this upper one in the in I haven't even, I didn't even write a t value in the upper one or whatnot because I realized that it doesn't make sense when I was watching more videos and stuff like that. So basically, you align the center of your left one against the upper one, like the beginning of the upper one, and then you use a formula to calculate the fucking the beta. And when I give the values of the upper,
What formula do you use to calculate the beta?
it's basically, like I got the formula, but I cannot tell you the formula right now, and like at the top of my head. Like, you gotta do subtraction, you gotta divide and stuff like that. And I have the formula. I can show you in a bit. And I got the formula to like do it right. And when you do it, because I just learned it, so I don't have it memorized yet. Um, but when you fucking come up with for example, the 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 beta result gives me like something like 0.0025025 something like that. And that pretty much gives us our beta, which is super minimal. And uh it will be like barely anything. Like it will be like this. Like it will correspond to this value. Like it will correspond to this value, like
What
here.
beta? What beta did you come up with?
What?
What beta did you come up with?
It was something like this, like this fucking tiny. It was like something like zero, like the beta, right? Will be something around here, which will be like 0.0025, and it will like like align with the alpha of fucking or null standard curve. Like it will be around here. Like if you align them like this, even by just getting the beta, it's like here, like it cuts around here.
So use beta.
What? You sound very far away.
Show what formula you use for beta.
Can you hear me? You sound very far away.
Yeah, yeah, yeah. I'm saying that you gotta show what formula you used for beta
Okay.
because your beta isn't right.
Because what?
For starters, your beta isn't right.
I can barely hear you. Like it's very choppy.
For starters, your beta isn't right.
Cannot hear you.
Give me, let me change that stuff.
Okay. So this is the formula I use: probability, and then t is greater than t critical plus t critical minus t null, and then um square root divided by standard deviation. And this symbol is like used to show how it differs from like the null hypothesis. You see it? I think I wrote
What's
it
a T
correctly.
no?
What?
What's the T no? Now? No?
Like the t value of the t the null hypothesis.
Uh,
It will be like the t critical of the null hypothesis.
no, you already have T
No,
critical.
no, no. Oh no, you're talking about t null. Like no, no, like the value of t null. Sorry, sorry. Like the t value, not t critical. Sorry.
T.
Yeah, yeah. And if you align them like this, if you align them like this,
No, you don't have like when you calculate beta, like T value that you come up with doesn't enter the formula. It doesn't affect the beta.
mm, wait, but okay. Even if you put like, for example, like just put like the values that what I was gonna say, I used. I mean, sorry, sorry. So the parameters that I use on this one, right, are for their own, not this one. My bad. I got mixed up. I use like their own parameters, and for example, in the bottom one, I use only like six, right? And in the top one, I use like all of them because we're using like all the values. By the way, disregard the values of the standard slope and stuff like that. Still under construction, and all the values of here, all this shit you see here, disregarded.
Okay.
So basically, I use like um the values of what I was gonna say, this fucking sample size. I use the what is it called, the this sample standard deviation. I used fucking the hypothesize
Yeah. So
mean
so 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 so
and
what,
the
what's going on?
sample mean and what?
So what I think is going on here is this is basically well, let's see. I'm not sure why there's Are you sure about the times square root of n divided by standard deviation?
Yeah, I mean, I believe so.
That's
Because,
like that's
but
and like inverse of
because,
the value.
like for example, give me a second. Uh, for example, if let me show you how I ended up putting it. Let me
So probability
basically
that
that.
when it said probability
Uh-huh.
t higher than t, that's the area under the curve. So that's the calculation of the area under the curve to the left of that t value
Mm-hmm.
or whatever the value. Uh, did you know that?
Yeah, I believe so.
Okay.
Also,
And that's also how the p-value is calculated. Well, p-value is the probability, right? So that probability of t is more than t is also the calculation of the p-value,
yeah.
because that's. Hey, I have like an inspection here, sort of really easy inspection.
Okay, we can talk
So
later.
I'll
Yeah.
talk to you
Yeah,
later.
alright, see you. Okay, so this apparently is meant to be like the alternative one, the blue one, and the white one is the null one, and the this one is centered at 43.
We are rejecting the null hypothesis if the sample mean is less than or equal to 40.
And we are
Don't,
rejecting the null
like don't
hypothesis.
call it don't call it alternative. I think you get really mistaken when you keep hearing and calling it alternative, and you miss the point. It's the true. It's either true mean, or it's the true mean that you believe to be true. Like, let's
Okay.
say somebody does experiment to prove something, right?
Mm-hmm.
Like, let's say someone does an experiment to prove that insulin is good for diabetic.
Mm-hmm.
They start with already an expectation, so they expect that insulin is like t equals 3, t value of 3 good for diabetic. Like it's like pretty far away from neutral, like
Yeah.
when diabetic gets insulin, he benefits quite a bit. So that's what they believe. So that's their believed true mean. So it's not, don't say alternative, say true.
True man.
True.
True
So
man.
even though they
Okay.
don't know for sure, that's the true mean that they believe, and they do experiment to prove that or to disprove that.
Yeah. Okay. I
So
fully get
even
them.
though they haven't done the experiment yet, in their mind they have the true mean, and to test if it's there, if it's if to accept
If
or
it's
reject their hypothesis based on their belief of the true mean.
Okay.
They can pick the number of samples so that their beta is low enough. And then
Okay.
when they do all their data, or like let's say they do like 1,000,000 times, then they can find out if what is the actually true mean, compared, if they want to compared to what they believe the true mean is. But it's not
Okay.
really alternative. It's the true. Whether it's believed true or whether it's actual true. But it's
Okay.
the true.
Okay. I'm gonna call it true man.
At least it sounds confusing to me, and I think it's confusing you as well.
Yeah. Okay. The true man.
5.31, and we're going to not.
And basically, he's just implying if it's like lesser than 40 5.31, we are gonna fucking reject the null hypothesis.
Reject the null hypothesis if it's greater than 45.31.
And if it's greater than 45.31,
So the probability of a type 2.
What is gonna say? He will not
Well,
reject
I mean,
it.
To
But
error
he-
in this
I mean,
spot is going to be the area to the right of this value.
Uh-huh.
it depends on
Given mu
so
is
you take your
actually
10 samples
43.
from the true distribution,
Let's shade that area in.
and they can
Uh-huh.
fall anywhere, when you take the average of those 10 samples.
I'm shading that area in red here
They can
because
fall
it's
anywhere within that blue curve of the true spread of the means, because you take the true 10 samples and they can fall anywhere there. So then there's a chance that they'll fall to the left of 45, and then you'll reject it, or there's a chance that those 10 samples from the blue distribution will fall to the right of 45, and then you will not reject your null hypothesis, because your null hypothesis and your your hypothesis is that white line, which is something you just kind of, that's your question. Is the white distribution is your question.
Yeah.
But the blue one is the true mean distribution. And so when you take 10 samples, they can fall anywhere within the blue. And if they fall to the left of the 45, then you reject your question. And if they fall to the right, then you'll accept or you will not be able to reject your question.
Okay.
I don't know if that makes sense.
I mean, yeah, it does. But what I was gonna say, like for example, in this example, he's like overlapping them, and on regards to like the values itself, and then after that,
Error.
he got like
Is the probability.
what?
Do you understand why he's overlapping them?
Yeah, because like he wants to basically find like a point where like you are able to like reject it and not reject it based on like the sample the sample means given for the true mean and the null hypothesis.
Well, it's the number. So that
Of
shaded
committing.
area.
Yeah.
So let's say you take 10 samples from the true distribution, and most likely their mean will be somewhere in the center of that blue distribution, because the closer to the center, the more likely that's what you end up when you get 10 samples. But there's a lower chance that the 10 random samples that you'll take, their mean will be in a shaded region, because it's a smaller area, or smaller area under the curve. So that's like probability.
Yeah.
And so let's say you take 10 samples 3 times, right?
Uh-huh.
So then you end up with 3 means, right? So the chances are one of those means will be in the left side of that blue curve, somewhere in the left side. One will be somewhere in the center of the blue curve, and one in the right side of that blue curve. Because it's like you're playing darts. You're just throwing a dart at that blue curve, and most likely the dart will hit somewhere in the middle of the blue curve, and it's much harder to hit somewhere to the right or to the left of the blue curve. And so to be able to get a sample 10 points where their mean is in the right side so far that you will not be able to reject your question, that's the shaded area. So imagine if you like throw 10 darts at that blue curve.
Yeah.
The percent of those darts that will land in a shaded area, that's a percent. That's your type 2 error. Only those darts will hit in an area where, in relationship to your question, you will not be able to reject your question. So if by accident the 10 samples you took was the only 10 samples you took, and it was that dart that landed in that shaded area, and then the average of those 10 samples will be higher than 45.
And if we go to the standard normal curve,
let's say
we can see that
47,
the area out
because
to the right
that
of
dart landed
0.6
by chance in a shaded area, and your mean of the 10 samples is like 47, then you will not be able to reject your question. But you should reject your question, because the true mean is to the left, way to the left of your question mean. So basically your question here is like, is it smaller or bigger than 50? That, I guess that's maybe that's the question here. And the true answer is right there. The blue one. The blue is the true answer, which is the true answer is yes. It's smaller than 50, but it's a distribution in a way that every time you take 10 samples, by accident you might be to the left or to the right of it.
Yeah.
And so if you take the wrong 10 samples and you end up with a mean of 47, then you will not be able to reject your question, because 47 is less than critical value of 45, or more than critical value of 45.
I have a
So you're
question.
not able to reject your question.
I have a question. How did he just overlap them like that? Like for example, with no, previous calculus or whatnot. Like, like the overlapping. Like, okay, it's like the what I think is like the
You
midpoint.
mean where to position the blue curve in relationship to the white curve?
Yeah. How did he just put them up like that?
Well, that's what I described in Paint, is the t-value. That's the blue curve. You can calculate how many t-values away the true mean from your question mean, or your mu naught. Well, mu naught will be centered on 0, t equals 0.
What's the
But then
formula?
you got to look at the Paint when I did the Paint thing.
Like the when you did the p-value.
Yes, but in that Paint, I wrote an equation where I calculated the t value, the distance in t values between the blue and the white. So white, it will be positioned on 0, t equals 0, and then the
Wait.
t value I calculated in that Paint is the distance to the blue center.
Wait, you did the one that calculates so far it goes? I thought that it was only like the t value, like the normal t value. Okay, I'm gonna wait. You did that? I did watch a Paint video. Okay, I'm tripping. I'm gonna watch it. Make sure that.
That I think that's the only t value I calculated in that video, is the distance from your question center to the true mean.
Yeah, I'm gonna check that. Okay.
Yeah, there you go. The t.
Okay,
so
so
to get the area
x
under this curve,
mu.
yeah, but that's just the normal t distribution.
So no. So here x is the x of your true x. So it's not your 5 sample x. It's the true x. Or in our case, we assume that 10 samples give us true mean.
Oh, okay. And
So
then
it's the x is the x of your true mean.
okay. And once you get that value, like how do you align it?
That's the distance between the center of the true mean and so the distance between the true mean and your null mean is the true mean minus null mean, right? So the distance in like normal units is between the two means is just one mean minus the other mean. But in terms of t values, it's just exactly that divided by sigma divided by square root of n. And in this case, yeah.
Okay.
So t value is basically a scaled mean, really. Scaled meaning that it's just divided by a number. And so like the distance between the center of this curve and that curve is just mean of that curve minus mean of this curve, like mu naught, x minus mu naught, where x is mean of the true mean and mu naught is the of the question mean in our case. But but that's on a normal units. But here our units are t values. In the x-axis there's t value units.
But
and so
isn't that like
that equation.
Isn't that kind of like what we want to do? For example, getting like the value of when it be getting like the value of x critical to try to align them, and then basically if they do not have like the same value, you look up for n, and then that n will help you solve the x issue, like in the video of Brendan.
Well, you asked me how that guy aligned his curves, and that's how he aligned them.
Okay. Okay.
By
But
using that formula.
huh. I'm fucking confused between what you're telling me
But
and what
that's
I'm looking
but
at
but
and from like the other guys.
well, he didn't. Well, I mean, if he didn't tell you how he aligned the curves, then the only information you have is what I'm telling you.
Okay. Cool.
So
Uh-huh.
there's an x value. There's an x value for the true mean, and then there's x value for your sample data set, which is
Uh-huh.
different because you sample from the true mean. You have the true distribution, and then you sample from it, and you get your 10 samples, for example. And
Okay.
those 10 samples give you like a sample mean that you happen to come up with. And then that mean has also a t. You can also calculate t value of that mean. So you can calculate t value of that mean. You can calculate t value of the true mean. You can calculate t value
Cool.
at the critical rejection line.
Uh, Whenever like you like actually like stop driving, could you, if I give you like the standard curves, could you give me an example of like how to properly do it? Because I'm very confused, bro. Now you
When this
confuse
is
me
the
again.
example we're looking at it.
No, but like with actual like true values is what I'm trying to talk about. Like not just like you know uh random shit. Like if it was like a proper
Well,
one.
yeah. So you I can tell you. So the mu what's the mu naught for the graph you were for any mu naught? What give me a mu naught, for example, that you want to do.
Okay, 1 second. Okay, so it will be 0.548.
Okay. So that's the x mu naught. So in my question, I think I use mu naught.
Okay.
So that value. Then what is the value of
The true mean?
Oh no, that's the second value. But yeah, what's the value of true mean of using all the points
Um,
after the treatment?
um, like what do you mean? Like you like the deep value of using all the points, or like just like
No,
the true mean, like
the
the the average. Okay.
average health index,
Okay, it
health
will be
index
0.041.
0.041. Okay, so then so the top part of the equation is that 0.5 or whatever you said. No, it's that 0.04 or whatever you said minus 0.5 or whatever you said for mu naught. You get it? That's the top part of the equation.
Uh-huh.
Is the difference in those two means.
Uh-huh.
That's also how far the top curve is to the right of the bottom curve, because if the bottom curve is at 0.5 and the top curve is at 0.04, the distance between them is one number minus the other number, right?
Mm-hmm. So what
Okay. So that's the top part of the equation. And then you divide that by the standard deviation divided by square root of n.
I get it.
So you have all those values, right?
Mm-hmm.
Yeah, and then that will give you a t value, or it will actually give you a t
But
value
okay,
as a
one
distance from
question.
one
One
curve to the
question.
other.
Um, will I be using those values out of like the sample size that we were trying to get, like the top or like the bottom one, like the standard
Right?
like will I be using the standard deviation of 6 samples like in the bottom one, or like all the samples like in the top one, like the number of samples and the standard deviation of which chart, the upper one?
So I guess the top one. I guess the true one. The true
So it
sigma.
will be all
True
of them,
standard
right?
deviation. Yeah, I guess I mean, that's where you have to kind of get creative and like try to improvise of what is the right way to do it. But I think the right way to do it is easy, because we're trying to get our beta, considering that we know the truth. So yeah, I think we use the true standard deviation.
Okay. And like the true sample size, right?
Yeah,
Uh-huh.
I
And
think
then
so. I think so.
yeah.
I'm guessing it's supposed to be a true sample size.
Okay, yeah, okay.
Or I mean, like what makes most sense,
Okay, now
I should say.
continue.
Yeah, and that will be the you will get your t the number of t values between one mean and the other mean. So if the bottom mean is centered on 0, then the top one will be at that t value.
So it will be
Not t value.
it will be the opposite value of mu, or like the true mean versus the bottom one. We will like subtract them, and then standard deviation divided by the square root of n, and then after that you divide the two values and then you come up with the distance.
Yeah, that will be the distance. So without dividing it by that sigma over n, you just get the distance in normal units. But then you divide by the sigma over n, and then you get the distance in t value units. So you just get, you change the units from like normal units and health index units to the t value units, number of t values between the two curves.
I have a question. Okay, so we did that t value, right, in mind. Fuck, I wish you could do like a visual representation. And it's like okay, once I give you the t value, like I'll do it really quick. I'll do the formula. Could you like help me sort of like visually tell me how will it be aligned in case I don't get it right?
Like the center of one curve will be that many t values from the center of the other curve.
Yeah, but like once I finish doing it and I try to do it, can I call you in like 2-3 minutes?
Yeah, that's fine.
And tell me whether I'm right or not, because I feel like I'm
Yeah,
fucking
yeah.
finally understanding it. Oh, thank you.
I just, well, I mean, I've heard you say that like every day for the last 4 days, and every time it's
What?
something else.
No, come on, bro. We just started doing this like like 1 day ago. What do you mean?
So yeah, no, it's been like 4 days that we've been redoing it, the same thing.
No.
Which is okay. I mean, it's a complicated subject. I'm not saying that's that's a bad thing. Like I said, it's more complicated than people think.
Mm, are you sure? No, I think we've been doing like two
Yeah.
charts for only like 2 days, something like that.
No.
Yeah.
Let's see. Wait, we've been on a type 2 error for like 3 or 4 days.
No, but you don't realize that he started like using like the t value, not the t value, sorry, like two charts like recently. Like if you look at the videos, he has multiple of the
Yeah,
type 2
we've
error.
been doing 2 charts for like the last 4 days, and we're like,
No,
you
2 days,
do
2
it,
days.
then I'd be like, no, that's not right. No, 2 days starts yesterday. Like today is the second day.
Well, 3 days basically, 3 days, yeah.
Maybe 3 days. I mean, I'm thinking 4, but who cares? It doesn't matter.
Yeah,
That's cool. Yeah. Try to make an extra step now with this new understanding.
okay. Yeah, I'm gonna do it. All right, I'll call you
Okay.
in a little bit,
Sure.
and I'm gonna finish my food, do the formula, and then I'll call you. Okay.
Okay, sounds good. Later.
Okay. So the value given was negative. Can you see?
Okay.
Can you see can you see the charts and everything or no?
Yeah, I see.
So the given value was negative 2.30. I mean negative 2.383 for like the upper value. Oops. Can you see?
Which one are we doing? Are we doing arginine
No,
or what?
this one is like lithium.
Lithium.
Yeah. So how will we center the with this given value? Like how are we gonna center the what was I gonna say? The standard curve.
So I'm not sure if I got the signs right, but basically it's 2.383 t values away. So let's say if your top curve, if the true mean is
Yeah, we
let's
got the
say
true mean.
what is it? Minus or plus? No, minus. Or wait, what is it?
I don't know.
uh,
I'm the one that is confused.
that's yeah. It doesn't really matter like which way we do it because we'll still be doing one tail t-test and it will still give exact same answer. But let's see. If lithium is healthy, that means the true mean will be more negative than the mu naught, which means I guess the top one will be on the left. So I mean I guess the signs are right. So the top one is supposed to be 2.3 t values to the left of the bottom one. Because our true mean, our lithium is more negative on health values than our mu naught.
Yeah, well, like
So yeah, it's definitely going to be on the left side.
yeah, but what will be the estimate? Obviously, what will be the estimate? How do you estimate like the where you position it? Like the T critical.
Yeah, it's the t value of the center of the top curve is 2.383 t values to the left of the center of the bottom curve, and the bottom curve is at the t equals 0.
How many values did you said?
Well, you calculated it right there. It's minus 2.8 or 2.383, and you see it's minus, which means it's to the left.
Yeah, but wait. So this basically will be the critical value? No, it's a T value, isn't it?
That's how you align them.
Oh.
That's a distance. That's the distance between the true mean and the mu naught in t values.
Oh.
Unit.
Okay.
Because our x-axis is the units of the x-axis is t value.
Okay, so
T value,
so this thing that I just calculated, is it the critical? Yeah, right?
No, it's the distance between your true mean and the mu naught in the t value units.
Okay.
Because your x-axis is in t value units. It's like 0, t equals 0, t equals 1, t equals 2, t equals 3. No, those are t values. So the units of the x-axis are t values, number of t values.
Fuck. Okay, so how? Okay. Okay, I get it. I get that part. Now the alignment. How does it go? Could you give me like a visual representation of how to make the alignment?
So you keep moving the top curve to the left until the center of the top curve. If you draw the line from the center of the top curve down, so that it will land on t equals minus 2.383 on the x-axis of the bottom curve.
It will land on where?
Land on t equals minus 2.383 on the axis of the bottom curve. So where the
okay, I get it. I get it.
Oh. Yeah, and that that will mean that the top curve is 2.8383 t values to the left of the bottom curve.
Okay, I get it. And okay, so I get it. Okay, now after you, okay, so for example, it will be let me zoom out. It will be around here. In other words, like
So
like the center will be around here. Uh,
yeah, yeah, yeah. You just keep moving to the left until it's at minus 2.8.
yeah,
And
yeah.
then your shaded regions are going to be flipped as well, I think, or maybe not. I don't know. But that's the true alignment of these curves. That's how they're aligned.
Okay, so yeah, here will be the alignment. Okay.
Yeah.
Oh, thank you, master. Okay, and then okay.
Oh,
Huh.
go ahead.
So okay,
I have another something funny to say.
go on.
I mean, it's about that equation, that n equation.
Uh huh.
Okay. Well, so I'm looking at it, and so here's the thing. So, like, if you look at the chart of Brandon chart, or of the chart you were showing me, well, we don't have z's, right? We have t's. It's t alpha plus t beta, right?
Yeah.
Okay. So the distance. So if you take the distance from the mu naught of the bottom curve to the t alpha in t values, and then add to that the distance from that t alpha, which is also the same as t beta on the top curve, because they're in the same place. So then you take the t from that t beta, or t beta to the center of the top curve. That's the total distance in t values from the center of the bottom curve to the center of the top curve. So that's the distance. So that t alpha plus t beta is minus 2.383. And then if you rearrange that equation, it's actually, I think it's exactly the same equation that I showed in that paint. But
No, it's not.
You rearrange it. I think it is.
No, it's not.
There's like,
On paint.
okay, you take a square root of everything. Yes, you take the square root of everything. That t alpha plus t beta is actually the t value that you calculate in paint. And then you multiply it by that. It goes to the left, n goes to the bottom, sigma goes to the bottom. Like, if you rearrange it, it's actually the same equation. But here you're calculating for n, where in my equation you're calculating for that t alpha plus t beta. I mean, if you take square root of everything, all of those squares go away, and then you have square root of n, which is what I have in my equation.
So,
but my t, the distance from the center of the top curve to the distance to the center of the bottom curve in t values, that's exactly the t alpha plus t beta, because t alpha is the distance from the center of the bottom curve to the critical value, and t beta is the distance in t values from that critical value to the center of the top curve.
I have a question. So now that it's aligned correctly, like the t is aligned to like the upper one, where fucking it what it should be, right, which is 2.383, and the critical area, which is like the 30% here. I mean not the critical area, the alpha here, it lands around here. So does that mean that our fucking beta will be very minimal, like it will be barely existent, or what does it implies?
Yeah, that's exactly what it means. It means that the beta is the error, is the chance, is what is the chance that you will not be able to say that lithium is. Okay, well, I mean, you got. We're saying, our question is it our null hypothesis is neutral or unhealthy, right?
No, it was like null hypothesis for one of them. No, for some of them it was like unhealthy
Yeah.
or neutral, and other ones was healthy or neutral.
Okay, so
For
that's
this one
because we have our
is healthy or neutral, yeah, and for the other one is
so
unhealthy.
our signs are a little bit different. So to say healthy, that means that it has to be to the left
Yeah, yeah.
because it's negative. So your shaded region is actually going to be in the bottom one. Your shaded region is actually going to be to the left because healthy is to the left and unhealthy is to the right. So neutral or
Yeah, no,
unhealthy is the
but in
center
this one,
and right.
yeah, but in this one is meant to be healthy or neutral, and the upper one is unhealthy. In this
No, because
example.
our healthy values are negatives.
Yeah,
Remember,
yeah,
our healthy values are negative.
yeah. I know. That's what it says. Like the null hypothesis, mu less or neutral than 0.041 uh, equals to unhealthy. I mean healthy. Sorry.
Oh no. Yeah. If it's smaller if it's smaller than mu equals 0.041, that means it's healthy.
Yeah, I know.
That's our alternative hypothesis. That's our alternative hypothesis. So if it's more than mu equals 0.041 or equals 0.041, then that means it's unhealthy or neutral, and that's our null hypothesis. And if
Mm,
it's to the left of that, it's actually healthy, and that's our alternative hypothesis.
okay.
So our shaded region is going to be actually on the left side because our healthy side is actually the left side.
Okay. Yeah, sure. I'll modify
Because,
them.
yeah, because our the more negative the healthy is, so our left side is our alternative hypothesis.
Okay. Huh. Okay. So what I was gonna say.
Yeah, and then you're gonna get the reasonable beta as well, because then the beta is gonna be everything. If you then like draw that line from the t critical, which is negative, like let's say -1 t equals -1. Let's say it's t critical. Then if you
Okay.
draw it up, then to the top curve, then everything to the right of that is the type 2 error on the top curve,
Uh, wouldn't
which will
it
be
be?
like here, like
Wait,
by the looks of it, will be like 15%.
15? How?
Well, again, if you draw the line from -1 up into the top curve,
Minus one.
it will land on.
Wait. Explain me that part. I'm confused. That part.
So I don't know what's a T critical,
For which one?
for the bottom one.
Yeah.
There's
Because
only
the
one T
values.
critical
Yeah,
here.
yeah. Because the values of this chart are not, set up yet. It's about like 500.
Like 0.5.
Yeah, positive 0 point fucking 500.
Well, I mean, once we switch it over, it's actually -0.1. I mean, it will be exactly the same, just on the other side.
Yeah. Okay, so it will
So
be negative. Oh, okay, I get it. So because it will be in the other side, it
yeah,
will be
it
around
will go up
here.
and then.
So it will be
Well, yeah,
around
I think it's
here.
going to be a little bit more to the left a little bit. But yeah, it's going to be like 10% beta of 10% or so,
I
or
think a
maybe
little
5%.
less.
It's
Yeah,
going to
yeah.
be small. It's going to be a small, but it's going to be like, reasonable, like real numbers beta, not some like 0.00.
Yeah, okay, makes a lot of fucking sense, bro.
Yeah.
Fuck.
Yeah, no, I bet you that if you rearrange that equation, it's going to be the same equation. It's just we're trying to calculate that z alpha plus z beta instead of the n.
The,
But we have t's and then
I think now I understand why this was like the final video in regards to like the hypothesis testing, because it was like the most difficult part.
well, especially considering that they don't have the name when they say that alternative hypothesis mean, that's like false. Like that's like
It's just
fucking
true main,
false.
right?
Like
Yeah.
it's fucking. You have the alternative hypothesis is the question you ask, and it can be fucking anything. Whatever the question you want to ask, that's your alternative versus no hypothesis. And like calling anything else alternative mean is like bullshit. Like that's just fucking false. And they fucking all keep doing it, and it's just fucking professors who like don't deal with the real data. They just fucking copy paste from textbooks and just they don't give a shit. They just write it on a blackboard, and they don't give a shit when a person actually has supposed to like use it in real
data.
life.
Yeah.
So,
Those
yeah.
fuckers.
But yeah, kind of now that I've watched it like a million times, I'm like, oh, that's fucked up. That's not a fucking alternative hypothesis mean at all. Like
Yeah.
that's they're basically misusing terms. Yeah.
Mm.
Anyways.
It makes sense.
Okay. Well, now you know how to fix it.
Yeah, I'm gonna fix it, and I'm gonna finish the first example and hit you up, and so you can take a look at it, and yeah, makes
Sounds
sense.
good, man. Later.
Later, broski. Mm. Okay, so I'm gonna talk about molecular hydrogen, or H2. It's a gas that consists of two hydrogen atoms that are covalently.
Wait, what are we talking about?
Molecular hydrogen.
Why are we talking about molecular hydrogen?
You will see. I mean, you'll hear about it.
Okay.
Okay.
Oh yeah, I know where you're going with
So
that. Okay, go ahead.
Okay, you want to start talking about vitamin C and vitamin D3? Okay, I'll switch the topic then. Vitamin D3.
No,
Take
I
your
mean-
vitamin D3 if you want healthy bones. Drink your milk, kids.
Yeah. No.
If you
But yeah,
want-
you talk about whatever you have ready.
Yeah. Drink your milk, take your vitamin C, and yes. No, I'm joking. What was I gonna say? The dark covalently bonded together. It is the smallest of and the most abundant molecule in the universe, and can be found in many natural sources, including water.
Are you recording?
Yeah, the atmosphere and the human
Okay,
gut.
cool.
The human gut. Molecular hydrogen is chemically inert and does not react with most other molecules, which makes it a stable and safe substance. Excuse me for the burp. Research has shown that molecular hydrogen has potential health benefits, including its antioxidant and anti-inflammatory properties. Molecular hydrogen can reduce oxidative stress, which is caused by an imbalance between the production of reactive oxygen species, or ROS, and the body's antioxidant defenses. When ROS accumulate in the body, they can damage cells and contribute to a range of chronic health conditions such as cardiovascular disease, diabetes, and neurological disorders. Molecular hydrogen can also help reduce inflammation, which is a normal response of the immune system to injury or infection, but can become chronic and contribute to the development of various diseases. There is research that suggests that the molecular hydrogen can help regulate production of pro-inflammatory cytokines, which are molecules that play a role in promoting inflammation. There are several ways to consume molecular hydrogen as a supplement. One of the most common ways is by drinking hydrogen-rich water, which is produced by dissolving molecular hydrogen gas into water using a specialized machine. Other methods include inhaling hydrogen gas or taking hydrogen tablets or capsules. Okay, molecular hydrogen H2 is a gas that is used as a component of exotic breathing gas mixtures for deep water divers to prevent wait, how do you pronounce that word? Decompression sickness. H2 has therapeutic properties as free radical scavenger and was shown to cause a significant regression of a skin tumor and leukemia in animals in the absence of explosion risk The antioxidant advantages of H2 gas include its ability to reach subcellular compartments like mitochondria and its selective scavenging of the deleterious, wait, how do you pronounce that word? Deleterious hydroxyl,
Deleterious.
yeah,
Yeah.
hydroxyl radical while preserving other important reactive oxygen and nitrogen species for normal signaling regulations. H2 is superior to some antioxidant supplements with strong reductive activity, such as vitamin C or vitamin E. There you go. H2 is now considered signaling gaseous molecule with psychological function similar to that of nitric oxide, carbon monoxide, and hydrogen sulfide, and has been shown to have pleiotropic therapeutic effects in a variety of animal disease models and some human patients. Um, uh, Molecular hydrogen has been studied in various administration forms, including 1 to 4 percentage hydrogen gas inhalation, hydrogen-rich saline injection or infusion, and oral intake of hydrogen-saturated water. H2 concentrations in tissues depend on the administered H2 concentration, and specific tissue of H2 uptake is related to the difference in administration route. H2 has therapeutic effects in multiple organs, including the central nervous system, cardiovascular system, lung, kidney, liver, pancreas, skin, eye, bone, and reproduction system. The underlying mechanisms of H2 therapeutic effects include anti-reperfusion injury, anti-inflammation, anti-apoptosis, anti-metabolic disorders, anti-allergy, anti-radiation injury, anti-dementia, anti-aging. The signaling pathways, the signaling pathway regulation effect of H2 by modulating various molecules, expressions, and activities. Gene expression and microRNA might account for the ultimate effects. Um,
Oh, are you forgetting to ask me about the daylight?
no, I'll send you a message.
And I answered it. That was like 2 days ago.
No. I send you a message right now. Like, what's your daylight? I send you a message in the text messages.
Oh, like recently?
Yeah.
Uh, I'm trying to remember. What can you see sunrise in Laredo, Texas?
Is the base that I'm like using to read good or not?
Huh?
Is the speed that I'm using to read, is it good or not? Am I using a comprehensible enough?
I think it's acceptable.
Okay. A comprehensive review by Ichihara in 2015 summarized the biological benefits of H2 in all organs, covering 31 diseases categories that can be subdivided into 166 disease models, human diseases, treatment associated pathologies, and pathophysiological conditions of plants. And I tried to look up for that thing and didn't seem to find it, but I did find studies about how it's helpful. I mean, a study that is helpful. Okay,
Yeah.
so a study of molecular hydrogen and hepatitis.
I try to remember to get the year because I always want to know what year was the study was done in.
Oh, okay. 60 patients with chronic hepatitis B were randomly assigned into a routine treatment group of hydrogen treatment. Wait, sorry. 60 patients with chronic hepatitis B were randomly assigned into routine treatment group or hydrogen treatment group, in which patients received routine treatment alone or additional oral hydrogen-rich water, and it was 1,200 to 100 and to 1,800 milliliters per day, twice daily, respectively, for 6 consecutive weeks. Serum oxidative stress, liver function, and HV, blah, 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 how do you pronounce it? HBV. Wait, when I see the little V, it literally sounds the same, doesn't it?
I don't know what you're saying.
What I'm trying to say is like when I say the letter B, it sounds like B and B sounds the same, doesn't it? When I pronounce it.
Similar. They sound similar. No, I don't think they sound the same
Okay.
when you say them.
Okay, and HVV, which stands for hepatitis B virus, DNA level were detected before and after treatment. 30 healthy subjects served as controls. 30 healthy 30 healthy subjects, 25 males, 5 females, for routine physical examination were recruited as control. They had no system diseases after the important organs, including heart, liver, kidney, and lung. The liver and kidney function was normal, and they had no viral hepatitis or were not the carriers of viral hepatitis. The mean age was, 35.8 plus minus 12.2 years. So the age range was 20 to like 55. In the routine treatment group, patients received routine treatment, and hydrogen-free water was administered to patients at the assigned time points. In the hydrogen treatment group, besides routine treatment, hydrogen-rich water was orally given 3 times daily, and it was at 8 to 9 a.m. It was at 2 and 3 p.m., at 6 and at 7. It was from like 8 to 9 a.m., 2 to 3 p.m., and 6 to 7 p.m. for 6 weeks.
And what did the controls get?
Just like your standard treatment.
So everything the same. Well, what's the standard treatment?
Like the standard treatment for people with hepatitis B.
Yeah, but as far as the water, did they get water three
No,
times a day?
No. Only one group was given only like their average routine fucking treatment, and the other one were given like the hydrogen-rich water.
I'm sure plus the standard plus the hydrogen-rich water. Like, there's no way they would take people and be like, hey, how about we take you off the meds and see if this hydrogen water will help you? That'd be super unethical.
In the routine treatment group, patients received. Oh yes, they also gave them fucking. Yeah, you're right. That will be literally like, fuck you. You die of having hepatitis. You fucking useless.
Drink some water,
Disease.
motherfuckers. Believe you. All you gotta do is believe.
Bro, they're like.
No, haven't you read the what is it? Oh, Peter Pan. Haven't you read the Peter Pan? Just gotta believe.
Yeah, bro.
And then you can fly.
You might never know. One of those fucking scientists or the people conducting the experiment was related to Jesus Christ, and he can turn that fucking water into like medication,
Yeah, they were like, well, you must not want to go to the Neverland because you don't believe enough to fly. You must not.
Oh, that's fucking funny, bro.
If we,
If
they
you
were
what?
trying to get people to the. They were trying to get people to the Never Never Land
Yeah.
in the treatment group. They're like, fuck, these people are not getting to the Never Never Land fast enough. Let's give them some hydrogen water.
Yeah, or
See if that makes a difference.
maybe they were like paid by the government to secretly kill them because they don't want to keep up paying for their fucking medicine, you know. It's a Radon's
Yeah.
program, you know.
Hey, maybe this hydrogen water will help you. Let's take you off treatments. You want to do that?
Let's gather 10,000
The truth
people.
is,
Huh? Go on.
the truth is, we don't have money to pay for medication, but we're not going to tell you that. We'll just tell you maybe hydrogen water will help you.
Yeah, that's fucking
Sign up for the
hilarious.
study.
Yeah.
But yeah. Okay,
Let's
so
gather.
but
Wait,
I
wait,
mean,
wait, wait.
it still
Wait,
sucks.
wait. Let me make a
Huh?
joke. Let me make a joke. Let's gather ten
Yeah, yeah.
thousand fucking diseased people from like with like different illnesses, different diseases, tumors, cancers, fucking hepatitis. Respiratory severe issues, and any
Like
underlying health
that
issues out
already
there.
sounds horrible.
And then let's give them fucking
Let's gather
yeah.
sick people,
Let's give them fucking
sick cattle. Let's gather the sick cattle.
yeah, yeah.
Cows.
And
Bunch of sick cows.
yeah,
Put them in one place.
and just give them hydrogen rich water and let's see how they react.
Let's tell them that hydrogen let's tell them that hydrogen rich water is the real shit, and they should try that instead of their medication,
Yeah.
because we don't have medication for them anyways. At least they'll feel good about not having it.
Yeah, let's tell them that this is the elixir, the magical fucking potion.
Yeah. And then Peter Pan was like, what the fuck, this Neverland is just fucking overpopulated.
Yeah.
What the fuck are people doing there on Earth? They call these fucking hepatitis B people back. It's like Neverland is full of hepatitis B people.
That's fucking hilarious, bro.
bunch of fucking tattoo, like, full tattoo, motherfuckers walking around. It's
Wait.
like, this hydrogen water isn't so bad.
Yeah.
I mean, that's how you. That's a lot of times that's how you get the Hep B, is by getting tattoos in weird places.
Wait,
Like,
actually?
Yeah, because they don't clean the needles well enough, they get infected with hepatitis B, if they go to a place that doesn't clean their needles or some shit like that.
Mhm.
Like, basically not sterile enough.
Mm-hmm.
And then like, that's where most of the hepatitis B comes from, getting tattoo at a shady place.
I see. I mean, I don't know. I have never gotten a tattoo myself. Like, I don't think that is like, well, you're talking about tattoos in general, right? I don't think that have a negative connotation about tattoos, but I don't think that I will get one myself. What about you, bro? What's your take on tattoos? Will you ever get one? Do you have one already?
I'm not into that shit.
Me neither.
I'm not into like mutilating my body.
Yeah, me neither.
I'm also not into bitches who have to. Well, my wife has like fucking
Gins?
full back tattoo.
Oh,
Yeah, my wife is into tattoos.
Jins? What about Jins? The
What?
like Jins, the character of League of Legends that you said that you like. That bitch has tattoos, I think.
I know, but she's like super ghetto.
Yeah.
I mean, maybe she was forced into it. Maybe
yeah.
that's her backstory.
Yeah.
Oh man, yeah, she's like, I was like, fuck, I love this bitch, but I would never go near
You
one.
love
but
the
whatever.
fact that she looks
Anyways,
extremely
let's go.
mentally ill. I'm joking.
Like, I mean, it's like my, a bit psychologically unhinged, I guess, is my type.
Yeah.
Anyway.
Yeah, let me continue. But yeah, what was I gonna say? A total of 185 chronic hepatitis B patients were
Oh yeah, I'm
recruited.
sorry. Wait. So, oh yeah, I was gonna say is that it still sucks. Like, in one place they force them to drink extra water 3 times a day,
Hmm.
and in another place they don't they don't drink extra water 3 times a day, which everybody says that drinking water, staying hydrated is good for you, right?
No, but I think that they're like like capable to like drink water, like they can drink water and shit like that. The only difference is
Well,
that
they
one,
can.
yeah, like the control group can drink water, right? But the fucking what is it called? Like the one that is being treated with the hydrogen water, they're capable of drinking water and shit like that. But 3 times a day, they have to drink the high hydrogen rich water 3 times a day for like 6 weeks. The other ones they can drink as much
but
water,
but
but it's not gonna be
but
rich in hydrogen.
but that's the problem, is that they're not forced to drink that hydrogen water instead of their any liquids that they're already drinking. Like, regardless of what their liquids that they're already consuming, on top of that, they still have to drink that hydrogen water, which I think I think generally it will end up meaning that they're more hydrated through the
Mm,
day. Because normally people don't even drink water, really. I mean, like most people, I don't think most people drink water.
I
They
do.
just fucking, like. I mean, you do, but I think if you take the average of all people, I think most people don't.
How much water do you
Maybe
drink?
like once.
You stay hydrated?
I don't drink water.
No.
I don't drink water. No,
Okay.
not at all. Zero.
Why?
I don't know. Just kind of, like I need to see some data showing that I should drink water. I
What?
haven't been able to test it. So
Bro,
I've been just being
when you're
I've been
when I
just
well, let me tell you something really quick. When I'm
oh yeah, I
hydrated,
do I,
I
I, I
feel
do drink a
extremely
little bit of
fucking
water.
shitty. Like that's literally one of the most important things in my opinion to like feel better. Like I'm not even lying. Like there is times in the past when I've been hydrated, like let's say 3 4 weeks, not weeks, sorry, 5 days, something like that. I have been barely drinking water, and I feel all lethargic,
Yeah,
unmotivated,
but
and then
think about your like how much does your dad drink water compared to you?
I have no clue. I do not measure it.
Maybe he doesn't drink water.
No, he drinks water. He has like what is it called? Um, how do you call those? Like
Mug.
those cylinders where you put like water and shit. Yeah, like yeah. I forgot what's the name. A
Thermos.
thermos. Yeah, thermal. Thermos or whatever that is called. Yeah, and he always has water on it.
But yeah, like I don't drink water per se, and fucking if
No,
I
you
was
need
not
to change that.
study, I would have to. I would have to drink, water 3 times a day on top of, whatever,
You
I eat or
definitely
whatever.
need to change that, bro. Like I'm telling you, give it like
Well, do your experiment. You gotta do your experiment and show me the real data. And if it makes a difference for you, like on the data, like based on the data that you take, then I'll try it. I'm not gonna try it, just because there's a theory about it.
okay for sure.
It's I don't have the motivation for it. I don't have the motivation to try it just based on a theory. Like the only way I'd be motivated to try it if like I had some data to tell me that, yeah, man, like I really should, change my way.
Okay, well, yeah, I'm gonna do it because I'm pretty sure that once there is the results, you're gonna like, and you start consuming water, you're literally gonna feel rejuvenated. You're gonna be
so
blooming.
so like the experiment would be 1 cup of water versus what, like 3 cups of water.
Bro, I don't drink a cup of water. I'll drink like 2 liters of water, 3 liters of
Okay,
water.
so the experiment would be 2 3
This
liters of
fucker,
water versus 1 cup of
that's fucking
water.
hilarious. You think that I only drink 1 cup of water?
Yeah, you take one sip with your pinky
Yeah,
out,
yeah.
and that makes you feel like a princess.
Yeah, bro, I feel all fucking hyped up after a fucking sip. I'm literally on crack.
Yeah. So the experiment would be 1 cup of water versus 2 3 liters of water. I don't know. Can you do that?
Not one cup.
I mean,
Probably
you can
like
drink,
probably like 2 cups. I will feel
but you
extremely
can drink as
thirsty.
much.
Probably like 2 cups is fine.
See, well, how often do you how often do you go to the bathroom? How often do you pee?
Probably like throughout the day.
I mean,
Um,
you need like seriously,
Probably.
like you need to check your A1C because I think your A1C is in a fucking pre-diabetic level.
You think so?
Based on what you're telling me, yeah, I'm pretty sure.
No,
I'm
but
pretty sure you have sugar problems.
you think so? No, but like I don't drink water because I feel like extremely thirsty. It's more because
I mean, you
it's
feel a little
healthy.
bit thirsty, right?
With like 1 cup or like 2 cups, I will feel thirsty, but not like utterly thirsty.
Well, well, try doing like 2 cups of water. That's
Yeah,
it
yeah.
per day. And if you feel very thirsty, you have sugar problems. I'm pretty sure. I'm like 90% sure
Okay,
you
yeah.
have sugar problems. If you feel thirsty after like having 2 cups of water like during the day.
Yeah, yeah. I'm gonna do it.
Because yeah, that's the problem. That's the
No, no,
problem is
but like,
that
what are you saying? In like
you
one go, or like throughout the day? Like, I feel like,
no throughout the day.
yeah, I feel like if I drink like 2 regular cup sizes throughout the day, I won't really feel like normal size. I will not feel
Yeah.
thirsty. Like one.
Well, yeah. Try that.
Yeah.
because because if you piss so much that you end up drinking 2 liters of water just to quench your just to not feel thirsty at all.
No, no, no. But that is not to feel
I'm pretty sure
thirsty.
you have.
Yeah, yeah. But I'm gonna do it. I'm glad that you're concerned. I'm gonna do it, and I will report you on that. But like,
Yeah, man.
but I'm
I
pretty sure
mean,
that it's not
then
because I'm trying to satisfy my thirst. Like, realistically speaking, the amount of water that I think that it's enough to satisfy my
do
thirst.
1 cup. Do 1 cup of water. You can do tea and you can do like any other drinks you do, but just 1 cup of water through the day. And if you feel thirsty,
Oh
like
yeah.
a lot, like through the day, then you have sugar problems. Well, I'm pretty sure you have sugar problems. I mean, considering that both of your parents have trouble with sugar, like
I'm
I'd be like
feeling
fucking ninety-nine
demoralized right
percent
now.
sure.
I'm feeling a little
I mean,
depressed right now. No, don't tell me
I
that,
mean,
bro.
I mean, I told you that I fixed it, like my shit with it, but like I investigated it so deeply that like now like I know quite a bit about it, and like based on
But
what you're
but but
telling
like, I
me,
barely eat candy. I eat like candy, bro, like once every like 5 days or like
it
one
doesn't.
week, and only
I mean,
like
it's
one lollipop or like one little chunk of candy.
it's not one thing, it's like everything put together, the whole, like there's so many different factors that affect it, like just fucking endless, and then
I'm not
it's
fat
how
or
all of
chubby or
those.
anything like that, though.
I don't know. You think I'm fat? I'm not fat.
No, but
But a lot of people are not fat. A lot of people who like your dad isn't fat
no, but
right
he was
now,
chubby when
and he
he
still
was
has it. But
diabetes. When he was
yeah, but right now he's not.
yeah. But I never been
Yeah, and right
chubby
now he's not,
myself.
but he still has.
Like, the only time I've
But
been
it's not.
chubby in my life, I was like eight
No,
years old. But yeah, continue.
yeah, it's not. It doesn't really have to do with that. Like a lot of people have diabetes without being chubby.
Fuck.
A lot, and it's just a lot of
Concerned.
factors.
I'm
It's a lot of
concerned, bro.
factors that. I mean, like it really fucking sounds like you have sugar problem. I mean, I think it's pretty easily reversible, to be honest. But but you tell me, like you just drink, limit yourself to 1 cup of water, and like if you get thirsty quite a bit, then like I'm like 99% sure you have sugar problems, based on the fact that both of your parents have sugar problems. I mean, like
No.
I'd be like 90% sure, but with your parents, I'm like 99% sure.
I mean,
But you do that test tomorrow or whenever.
yeah, yeah, I'll do that. I mean, in my opinion, like, for example, since I mean, but how can I explain it? I tend to like barely drink any other drinks, like, so, like, for example, I will like eat.
I don't know.
Yeah, I
I don't
will.
really drink well, I drink coffee. Like I drink coffee like Well, I don't even drink coffee. Like I do my blended food, and like I throw a bunch of stuff in there, and I use coffee as the thing, to mix it with.
I mean, so are you telling
Um,
me I should like substitute other like drinks that I drink? Like for example, with like a meal, I tend to drink it with like water or whatnot, or sometimes with juice, but barely. So the majority of the time I drink water, but like I don't do it because of like thirst wise. Because thirst wise, I think that I will just need like
so
three,
so so like
4 cups.
so maybe like a one cup of liquid with per meal for 3 meals. So like 3 cups of
Yeah,
that I mean that's pretty normal. Like like
yeah, yeah,
that's pretty normal to have something like a cup to drink with after the meal
yeah,
or
yeah.
whatever.
So like three cups
So
of
that
any type of
yeah
drink except water.
yeah no like 3 cups of anything including water. You can do
Okay.
water, and then on top of that plus 1 cup like
Oh
outside of
yeah,
the
that
meal.
definitely. I'm not gonna filter cereal now, but yeah, I'm gonna do it.
Well, I mean that's gonna be a lot less than 1 or 2 liters.
Yeah, yeah. No, but like, like I sometimes do it. Not like I do it not because I feel thirsty. It's because I'm trying to fulfill the criteria of like what's considered, the uh
But
the
you should
adequate
still check your
consumption.
A1C. You should
Yeah,
still go to like a doctor and check your A1C.
yeah. Yeah,
I mean, especially like yeah, like that's shit. Like people check it like for like no fucking reason at all, and like you actually have a reason to check it,
Wait, are you?
because
My
of
dad has like
genetics.
one fucking little device that it pierces through your skin. I think, or maybe I don't know if he has
No,
it or
that
not.
checks sugar.
Yeah,
Yeah,
yeah.
it's different. It's different. It's not what you want. You like it wouldn't tell you that much unless you're like a fucking expert in sugar. But like once you A1C, like it basically is the level of your sugar control for the last month, on average.
Hmm.
So it's like it's like a month worth of sugar control
Yeah,
is just that one
I, I,
A1C.
I might do it, but I want to see what the
You
results are
should.
of the first of like whether I feel thirsty or not with like
Yeah.
the 4 cups in total, like 3 meals and one extra cup.
Yeah. That I think that's pretty normal amount of liquid, for people.
Yeah.
Like I feel like people just fucking that's about what people do. I feel like I don't
Mm.
know. Um, but I mean, yeah. But I mean, regardless of that, you still should like get your A1C reading. Like I can't imagine it being expensive at all. I mean, it should be like super cheap to do
Like
or
how
free,
much?
depending. I mean, it's like fucking, I don't know, like if in the United States, I don't know, maybe $15 to check your A1C if like you don't have insurance, without insurance or anything,
Oh, okay.
like maybe $15. But I mean, like even if you have to pay full price, $15, like you should definitely get it.
Yeah, yeah. Yeah, I might do it for sure.
Yeah, like I get it. Like I just check mine for like random as part of everything, like once a year
Like a
for like no fucking
protocol.
reason really. Yeah, like and a lot of people do it anyway. I mean, it's just something people like think that it's a good idea to keep an eye of
Mm.
regardless.
Yeah, yeah. I
But
might,
yeah, man.
I might check it and taking like okay, like I'm gonna take in consideration how I feel with the experiment of going with like 1 cup of water, like four in total for a few days, and
Well,
depending on the
how about this? Like you can drink as much liquid as you want to with the meal,
yeah,
like 3 times a day. But outside of those 3 times a day with the meal, like you only get one normal cup of water.
yeah, yeah.
But with meals, I mean, you can like because like it depends on the meal and like you don't want to with a meal you can drink as much as you want to.
Okay, yeah, for sure. Yeah, I'm gonna do
Yeah,
it. Yeah, and I'm
yeah.
glad
And
to.
then outside of the meal time, just 1 cup. Yeah.
Okay, I'm gonna do it. Um,
Cool, man. I mean, do it just one day, and after that we just do our experiment.
okay. Wait, what experiment?
What 1 cup versus staying hydrated.
Okay, so like 3 cups. Yeah, like 3 cups plus the
Oh,
one.
just drinking as much as you want to with a meal, plus 1 cup outside of the meals.
Yeah, and that'll be like depending on the number that
Yeah, one.
rolls.
Yeah, yeah. Unless you tomorrow you're gonna feel super thirsty all day, and then like we'll assume that you have sugar problems, and then that experiment doesn't work anyways because your body just pisses out all the water, and like you obviously need extra water to stay hydrated.
Oh, okay, yeah,
So that experiment wouldn't even work. But yeah,
makes sense. Um,
yeah, we just do that, and then if you're fine, then we do the experiment.
yeah, for sure. I'll tell you the results.
Cool,
Um,
man.
what I was gonna say? Where did I leave it? Okay, yeah. A total of 185 chronic hepatitis B patients were recruited, and 101 met the inclusion criteria. And 84 patients were randomized into a routine group. 41 in the routine group, and the hydrogen was 43. Like where they were taking their standard treatment, and on top of that, the hydrogen water. At the end of the study, 30 patients in the routine treatment group and 30 patients in the hydrogen treatment group were included for final analysis. The study found significant differences in certain parameters related to oxidative stress between healthy subjects and patients with chronic hepatitis. Before and after treatment, these parameters remained unchanged in healthy subjects and routine treatment group. However, the hydrogen treatment group showed significant increase in SOD, and SOD stands for superoxidative dismutase, and is an antioxidant enzyme that helps to protect cells from oxidative damage by converting the superoxide radical into hydrogen peroxide, which is then neutralized by the antioxidants. Superoxide dismutase is an important enzyme in the body's defense against oxidative stress, which can lead to tissue damage and diseases. And okay, so hydrogen treatment group showed significant increase in SOD and GST activities and decrease in GCT stands for glutathione S transferase. How do you pronounce this word? Transferase. Yes, is an enzyme that plays a key role in detoxification.
Transferase.
Transferase. Yeah, is an
Yeah.
enzyme that plays a key role in detoxification by catalyzing the conjugation of glutathione to various electrophilic compounds. This process helps to neutralize and eliminate toxic substances, including those generated by oxidative stress. Okay, so the SOD and GCT um, levels showed significant increase in the hydrogen group, and it decreased the MDA and XOD. The MDA is the malondialdehyde, which is a byproduct of lipid peroxide. Wait, how do you pronounce it? Word? Peroxidi, peroxidation. Yeah, there you go. Is a byproduct of lipid peroxidation, a process in which free radicals attack unsaturated fatty acids in cell membranes. MDA is considered a marker of oxidative stress and is associated with tissue damage and inflammation. And it also decreases XOD, which is xanthine oxidase, is an enzyme that plays a role in the production of uric acid, which is important and is an important antioxidant in the body. Um, exact.
What? Wait, what? What? Who? Which? One of the groups had more uric acid in their blood.
So the hydrogen treatment group showed a significant increase in SOD and GST activities, and decrease in MDA and XOD activity after the hydrogen treatment.
No, I'm saying uric acid. Which one had more uric acid in their blood?
The one that didn't take it.
Oh, the one that didn't do hydrogen had more uric acid in their blood.
Yeah,
Okay, yeah, and I'm pretty sure that uric acid is not something you want in your blood.
Yeah,
The less, the better.
yeah. So XOD is an enzyme that plays a role in the byproduction of uric acid, which is important antioxidant in the body. However, excessive activation of XOD can lead to the production of free radicals and oxidative stress, but particularly in the context of ischemia reperfusion injury. And okay, uh, when compared with those before treatment, additionally, SOD and GCT activities increase significantly, and MDA and XOD decrease markedly in the hydrogen treatment group when compared with the routine treatment group. The SOD and the GCT activities after hydrogen-rich water treatment were higher than those in the controls. Do you want to see like the table with values? You want to do the screen share?
No, it's fine.
Okay. Do you want me to tell you the values or not?
Well, I mean, actually, I guess, let's see. No, don't worry about it. Like you can just say which one is more or less. It's fine.
Okay.
Or like how much. I mean, like if you think that there's something important, you can just describe it.
Okay. Well. Okay. On the what I was gonna say, in the control group, right? Before treatment, it was 80. The SOD levels in the control group was 84.6 plus minus 6.5, and after the treatment,
What's SOD again?
SOD stands for superoxide dismutase. Isn't an
That's a good thing, right?
yeah.
Okay.
It protects the cells from oxidative damage by converting the superoxide radicals into hydrogen peroxide. Yeah. Um. Wait. Okay. So basically, wait. Let me blow my nose really quick. Okay. So basically, on SOD, it was 84.6 and plus minus 6.5, and after the treatment, it was 54.9 plus minus 11.1, and for the hydrogen treatment, before the treatment, it was 84.9 plus minus 8.2, and for after the treatment it was 106.8 plus minus 100.7. I mean, not 100, 10.7, sorry. So like the after, it was 106.8 plus minus 10.7, so considerably higher compared to the routine treatment. Are you there?
Yeah, I'm listening.
Okay, for the routine treatment in GCT, which is glutathione S transferase, um, the before the treatment it was 93.4 plus minus 9.2, and after treatment it was 94.6 plus minus 9.2, and the hydrogen treatment it was 93.6 plus minus 9.3 before the treatment, and after the treatment it was 109.6 and plus minus 9.6. I'm just gonna tell you like the ones of after the treatment because I guess are the most important, don't you think? Or do you want to tell you the before treatment?
I mean, before and after, yeah.
Okay, before and after. All right. So MDA,
I mean, if there's a value you find important, then I would definitely want to know the before
yeah,
and
yeah.
after.
Okay. So MDA, uh, for the control group, it was seven the before. In the MDA levels, it was 7.4 plus minus 2.6, and after it was 6.6 plus minus 1.4. And the hydrogen one, it was 7.2 plus minus 2.6. Unlike the before treatment, and 7.2 plus minus 2.6. And after the treatment, it was 4.8 plus minus 2.7. So yeah, considerably lower compared to the control group. And on XOD, or
I feel like just drinking extra water 3 times a day could do that.
you think so?
Yeah. Which makes it a very interesting experiment for us to do to see the health impact of drinking water 3 times or 5 times a day or however many you drink.
Yeah. Um. Yeah, it's gonna be a very interesting experiment for sure. Um. So for the control group on XOD or xanthine oxidase, um, the before treatment it was 16.4 and plus minus 2.2, and the after was 16.8 plus minus 1.8, and the for the hydrogen treatment before treatment was 16.9 plus minus 2.6, and after treatment 15.3 plus minus 1.7. In chronic
Okay.
hepatitis V patients, the alanine transaminase and total bilirubin reduced, and what's the word I'm looking for?
I mean, basically now, like I'm listening to that, I'm just thinking of the health effects of drinking extra water. Is what it is. It's like drinking extra water reduces your bilirubin.
Yeah,
Like that's the perspective that I'm fucking taking right now.
yeah.
Is the effect of drinking extra water.
Okay. What I was gonna say, Aldo, if I'm not mistaken, when I was like looking at the prices of like the supplemented fucking capsules of uh molecular hydrogen, uh, it was like $20 or $30, like for I don't know 60 capsules. So I mean, if it actually has a benefit in people's health, like people tend to say, I guess I don't know. I will take it
Well,
if it was
I
necessary.
mean, we'll definitely need to see a study with the capsules or a study with the hydrogenated water where controls also drink water.
I could try to find more studies about that. I mean, I
Yeah,
could try to
yeah.
find a study like that and more studies about.
Because this study basically says the benefits of drinking extra water 3 times a day.
Yeah. Um, what I was gonna say. So, in chronic hepatitis patients, the alanine transminase and total bilirubin reduce, and cholinesterase increase significantly after treatment, with a p-value of lesser than 0.01 or 0.05. When compared with routine treatment group, the liver function remained relatively unchanged in the hydrogen treatment group, and the p-value was greater than 0.05. The alanine transminase and total bilirubin is slightly reduced, and the cholinesterase increased slightly. Um, what I was gonna say, after treatment, the HVB, or hepatitis B virus DNA in the hydrogen treatment group was
You can say people say Hep B.
okay, like Habibi. You know that word?
I don't know.
You know?
No.
Okay. I mean, I watched some videos and shit like that, and like apparently that's a way of like saying like dude or friend in Arabic or some shit like that. Apparently, I think. I don't know. But yeah, sounds like it.
Maybe.
So,
I don't know.
yeah, yeah, I think it is. So it is. I think. I don't know Arabic, but yeah.
But, but yeah, people just say Hep B.
Habib. Okay, happy.
If that's easier for you,
Okay.
per se.
Yeah. Um, okay, after treatment, the Habi DNA in hydrogen treatment group was comparable to that in the routine treatment, although the Habi DNA reduced to a certain extent in the hydrogen treatment group. And
Hey, I wanna hear one more time. If you've already said it, did they look at the uric acid levels in the blood?
yeah, with the XOD. It's an I mean, not the uric acids, but like the XOD, which is xanthine oxidase, is an enzyme that plays a role in the production of uric acid. That's what they looked into.
I wish they said the amount of uric acid, because like the theory is that if you drink more water, that you clear out more uric acid out of your blood faster because they turn over. I mean, water goes into blood and then it comes out of the blood through the kidneys. So the more you put through it, the more uric acid you remove. But that's I wish they had that value. But anyways, okay.
Okay, so here there is a chart where there is the alanine aminotransferase. It's an amino acid found in the liver cells that helps metabolize proteins. Elevated cells of alanine aminotransferase in the blood can indicate liver damage or disease. And there is the total bilirubin chart, the cholinesterase chart, and not the chart, sorry, like the table cells or marks points or whatever mark points you want to call it. And there is another one for heavy DNA, and I'm gonna tell you the results. Okay. So for
Okay.
the control group on the routine treatment was 210.1 before. That was like the before treatment, plus negative, plus minus 90.0, and after it was 68.0 plus minus 38.6, and for the hydrogen treatment it was 220.5 plus minus 95.0 on the before treatment, and after treatment it was 54.8 plus minus 34.6. On the total bilirubin on the control group before treatment, 45.5 plus minus 21.0, and after treatment,
I think bilirubin is basically a function of kidneys, and that's like super closely related with how much fucking liquids you drink versus how much you excrete, and like bilirubin is basically like directly related to that. So like if you suddenly drink way more, that's like a direct effect on bilirubin. So the fact that bilirubin really was affected, it just fucking makes sense. If you drink a lot more water, it's gonna be really affected.
yeah. What I wrote
But
down,
yeah, okay, go ahead.
okay, what I wrote down about bilirubin, it's a yellowish substance that is produced during the normal breakdown of red blood cells high levels of bilirubin in the blood can cause um, jaundice and can be a sign of liver or gallbladder disease.
Oh, I'm wrong. Uh, I guess I don't know. I didn't. I guess I was wrong about that. Maybe I didn't remember right what bilirubin is. So the liver takes bilirubin out. Wait, what? Say that
Okay,
again.
it's a yellowish substance that is produced during the normal breakdown of red blood cells.
Oh,
And high levels of
and the liver.
bilirubin in the blood can cause, diseases in the liver and the gallbladder.
No, no, no.
Well,
They don't cause the diseases. Like
no,
if something
no,
doesn't work
wait.
right.
As it's like a sign. Sorry. Well, it's like a sign of high
Oh, okay.
liver. It's like a sign of like liver and gallbladder
Liver
diseases. Like if you have high levels of bilirubin.
dysfunction,
Yes.
like liver gallbladder dysfunction.
Yeah.
So I guess the liver is the one who is taking it out. And basically, I think that like kidneys, take shit out and put it in piss, and liver takes shit out and put it in shit, like back into the, that's what you shit out. Um, and okay, so the bilirubin was what was that? What was the so bilirubin improved, right?
Yeah. The bilirubin levels in the hydrogen group improve. Like for example,
Yeah.
in
I mean,
the after
I mean,
treatment, it was for the control group was 22.5 plus minus 25.3, and for the after of the hydrogen treatment, it was 16.7 plus minus 9.6.
yeah. I mean, it's not a great difference. I mean, it's a difference, but also like just at some point, like I've heard that uric acid is really bad for a person, and like the older you get, the more uric acid you get in your blood, and it basically is bad for everything. And so if you drink more water, I'm pretty sure you clear out more uric acid out of your blood, because you just fucking liquid goes into blood goes into kidneys, and it then goes into piss, and like the more you go through that, the more uric acid you clear out, and then it affects every fucking organ in your body at the end of the day. So it could be still related to just drinking more water, but okay, go ahead.
Okay. What was I gonna say? Oh, also, on regards to the experiment we wanna do, usually it doesn't take me like one day to feel dehydrated. Like I will feel dehydrated after.
No, but it will take you one day if you have big sugar problems.
Oh, okay.
So like, yeah, if in one day you're not like fucking super
Dying.
thirsty, then we're good. I mean, just super thirsty, but then we go ahead with our experiment.
Yeah, for sure. I'll tell you. But yeah,
Yeah.
okay. So for the cholinesterase, cholinesterase levels, for the control group, the before values or like before treatment values were 6.7 plus minus 1.5, and after treatment it was 7.2 plus minus 1.4, and for the hydrogen treatment it was 6.7 plus minus 1.5. It was before, and after it was 7.7 plus minus 1.4, and for the HBV or heavy DNA, the before values for the control it was 5.55 plus minus 2.08, and after treatment it was 4.88 plus minus 2.1,
20%,
2 point,
20% change.
2.60, and in the hydrogen treatment it was 5.07 plus minus 1.93 on the before treatment, and after treatment it was 3.89 plus minus 1.52.
That's horrible, man. The fucking margin is awful.
Yeah.
So it could plus based on plus minus, it could have been like fucking 5 before treatment, and based on the plus minus confidence level, it could have been 4 before treatment. Like the error, the random error is so high that it might have been 4 before treatment and 5 after treatment.
I see.
But yeah, it's fine. Like I mean, it literally sounds like, you know, they basically had B DNA in the blood. There was no statistical change in Hep B in the blood. Like if you do your like the confidence interval, like it's all within the confidence interval. Like it might have been the same or basically before and after. Like the ranges overlap.
I see. I mean, and how does that like like a margin of error like that? How can it like totally affect the fucking study? Like it could like lead. How could an error like that could impact a study?
No, I'm talking about specifically the effect of
Yeah,
like
the
there's no
HV
even there's
DNA. Like,
yeah.
but I'm like curious. Like, if there is a margin of error there, or it's not as precise, it could like how can it impact the credibility of a
yeah.
study or whatnot?
Yeah, so let me put it this way. So drinking a lot of extra water makes you healthier
Yeah.
in all the other parameters you said. But when it comes to your disease of virus in your blood, like amount of virus that makes babies, you know, Hep B is a virus that makes babies, and the more it makes babies, the more Hep B DNA there is.
Yeah.
And basically it says that before and after treatment, there may very well have been the same amount of Hep B virus making babies. So the hydrogen water didn't actually affect the hepatitis B itself. Like it improved a bunch of health parameters, but when it comes to hepatitis B itself, it actually didn't affect it at all. Like it didn't, there was still the same amount of hepatitis B before and after, like because the ranges overlap.
Interesting.
Yeah, I mean, it basically goes back to the point that drinking extra water may actually be really good for you.
Yeah. So the overall results of the study showed that hydrogen-rich water treatment, for 6 consecutive weeks was associated with a significant improvement in oxidative stress, liver function, and viral load in patients with chronic hepatitis. Specifically, the study found that high-rich water treatment resulted in significant increase in superoxide dismutase or SOD and glutathione S transferase or GCT activities, and significant decreases in malondialdehyde or MDA and xanthine oxidase or XOD activity, which are all markers of oxidative stress. Additionally, the study found that hydrogen-rich water treatment was associated with significant reduction in alanine aminotransfers or LT.
So another question for you is effect of hydration, either effect of hydration or drinking extra water on XOD.
Wait, say it again.
Like studies Look for studies that study effect of drinking extra water every day, or maybe just staying hydrated, or
Yeah.
maybe or being dehydrated, an effect of that, of being dehydrated or extra hydrated on XOD.
Wait, on XOD specifically?
And or uric acid in the blood, in serum, blood, they're synonyms.
Okay.
But yeah, either XOD or uric, and also, like, for the fuck of it, relationship between the fucking XOD and uric acid, if anything, on that.
Like a study that has to do about that, or like just like a relation between those two?
Okay, if you look at the studies on hydration and drinking extra water,
Yeah, yeah.
and if they don't look for uric acid, but they look for XOD, then, like, we need more information on how XOD is related to uric acid. But I'm thinking that maybe those studies will not actually talk about XOD. They'll just talk about uric acid specifically, between if they talk about either XOD or uric acid, they'll end up talking about uric acid. If they have to pick, I feel like most people will pick talking about uric acid or measuring it.
Okay.
But if it happens that they're like focusing on XOD, then we need to know the relationship between XOD and uric acid. But if not, then we don't care about XOD, because I don't
Okay. What if I try to look? Obviously, I will put the time to look for studies about drinking extra water, or being dehydrated, or drinking water every day. But what if I look at multiple and like they don't have anything related with like XOD or uric acid? Like, do I use that?
Yeah, I mean, then that's what you'll say. Like, just spend some time looking for them, and if you find any,
And if not,
you let me know.
I'll just use studies of water that even if they don't have anything
Yeah,
related.
I think that's a good idea, right?
Yeah, yeah.
I mean, if we're gonna do an experiment, we might as well research more into it, maybe.
Yeah, yeah, for sure.
But specifically,
I
I
know
am
XOD.
interested in the effect of drinking extra water on fucking uric acid and XOD.
Yeah,
Yeah.
I'm gonna look into it. Don't worry.
Cool, man.
And what was I gonna say? The study found that or basically hydrogen-rich water treatment was associated with the reductions of alanine aminotransferase and total bilirubin, and significant increase in cholinesterase, which are markers of liver function. However, the study did not find significant difference in viral load between hydrogen-rich water treatment group and the routine treatment group. Overall, the
That's
results.
exactly what I said.
What?
The viral. That's exactly what I
Yeah, on the
said. The
viral
viral
load.
load, meaning the DNA of the Hep B.
Yeah. Treatment group and routine treatment. Overall, the results suggest that the hydrogen-rich water has might have a beneficial adjunction therapy for patients with chronic hepatitis B.
Extra water.
Yeah. uh, I'm gonna jump into the statistics for the argument.
I mean, you gotta say them out loud.
Oh, okay.
You gotta talk about
Okay.
everything.
So like the T critical that I ended up with after making the subtraction of the T value of orthromin and the T critical
So
value.
you calculate T critical regardless of that. You calculate T critical just based on the bottom chart.
Which will be like C or whatnot. Um, And what I was gonna say.
Oh, that's a T. There's no Z's here.
No, but like it all. Well, I guess that's just confusion. But fucking Brendan brainwashed me. But yeah.
Right.
Anyways, so basically, yeah, the D value of the upper chart, or the T score, sorry, ended up being like negative 0.661, which lands around here, right? And the in the trimming, which I use like the parameters that you want me to use, like all the sample means and like the sample size of of 5, and the sample standard deviation of all the samples. And obviously, we use this the
Hypothesize.
hypothesize mean of the value, the bottom area, or like the null hypothesis. And here we have our null hypothesis, and the top is our true mean standard slope, and the bottom one is like is equal or greater than. Top one is less than. And yeah, here are the values, and it turns out that it's like slightly healthy. Now, fish oil. Fish oil is a dietary supplement that is extracted from the tissues of oily fish, such as salmon, mackerel, and
Wait,
sardines.
did it get rejected on a hypothesis?
In the wait, was it in?
So when you did that, was the T value outside of the T critical? Like,
It got rejected on the bottom one.
okay, it was rejected, so okay.
Yeah, it got rejected. In the upper one, it did not get rejected.
Well, upper one is not really rejecting anything, and the upper one is different.
Yeah. In fish oil is a dietary supplement. So basically, the value that we got here for the T value is like negative 0.684, and the T value is like negative 0.549.
Yeah, that's just the T value of how far the mean of the top is away from the bottom, right?
Yeah.
Yeah, but you don't use that to do any hypothesis testing at all.
Oh, okay.
That's just where you place the curve.
Okay. Fish oil is a dietary supplement that is extracted from the tissues of oily fish. 1 second. Of oily fish such as salmon, mackerel, and sardines. It is rich in omega-3 fatty acids, which are a type of polyunsaturated fat that has been shown to have a number of health benefits. There are two main types of omega-3 fatty acids found in fish oil: fuck. Okay, help me out with this word. Eicosapentaenoic.
Let's see where it is.
Right next to where it says fish oil. Eicosapentaenoic acid and
I don't see, but I believe you.
Okay, and doco
What?
docosahexaenoic acid. These fatty acids
Oh,
are
DHA. I think that's a DHA.
decohexaenoic.
Yeah. So the D one is a DHA and the E one is EPA.
Oh yeah, these fatty acids are important. What? Go on. No, go on.
Yeah.
If you wanna talk about
Yeah,
it,
that's what when you look on the bottle, on a fish oil bottle, it will tell you how much DHA and EPA it has. Those are DHA, EPA.
Oh, okay. These fatty acids are important for the proper functioning of the body, particularly the brain and the cardiovascular system. Some of the potential health benefits of fish oil include heart health. Omega 3 fatty acids have been shown to help reduce the risk of heart disease by lowering triglyceride levels, reducing inflammation, and improving blood pressure and cholesterol levels. Brain health DHA is an important component of brain cell membranes, has been shown to have a positive effect on cognitive function and mental health. Joint health omega 3 fatty acids may help reduce joint stiffness and pain in people with rheumatoid arthritis. Eye health DHA is also important for the health of the eyes and has been shown to help reduce risk of age-related macular degeneration. And here are the values of our
Oh, wow.
fish oil. In the upper one is negative 1.527. Um,
Oh, wow.
the null we've obviously rejected.
So there's, well, go ahead.
What? No, go on.
So A, wait, what? Okay, so I mean the T value we got is pretty much somewhere in the center of the true population, which is like pretty much expected, right?
Not
You know,
really
you
in the
expect to
center.
get the
It's like here.
Well, the T value we got for our, what, 5 points? How many points did you use?
5. It's here. It's here. Yeah, it's here.
Oh, oh,
And in the top one
okay,
is for
yeah,
all the
well,
points. Remember?
okay. So just using 5 points, we got the T value of minus 1.7,
Yeah.
which is pretty much around the center of the top true population.
Yep. Yeah.
Which
yeah.
is, you know, what we can expect, you know, is we expect most of the points, if we keep redoing it, like most of the time we'll get something near the center of the true population.
Yeah.
So us getting T of minus 1 point whatever is pretty much expected, since that's about the center of the top population.
Yeah.
And obviously we reject our hypothesis that, you know, fish oil is bullshit.
Yeah.
But there's just, I guess, 16% chance that we might have picked, you know, we might have ended up with a value where
A not
we wouldn't
value.
have been able to, yeah, too far in the right.
Yeah.
I mean, yeah. So basically for fish oil, we might want to use more than 5 points. So like basically for every supplement, we might need to use like 6 points to make sure that, you know, our type 2 air is at least like 10%, you know?
I mean,
Like 16% still seems high.
Yeah, I mean, you were the one that told me to use 5. I will have used more if you had told me, but yeah.
No. In this case, we look at what happens if we use 5.
Okay,
but
okay.
when
It
we
was
use a
just
new
experiment.
supplement,
Yeah.
yeah. So, but when we use a new supplement, and let's say it's as good as fish oil,
Yeah.
but when we only use 5 points, there will be a 16% chance that we will not catch it. You know.
Okay, yeah, makes sense. Yeah.
So like if we want to find like another supplement that's as good as fish oil, we'll probably want to use at least like 6 points, so that I know our type 2 error, the risk of not catching it, if it's really healthy, is at least, you know, like 10% range.
Okay, got it.
Yeah. Okay, cool, man.
Resveratrol. Resveratrol is a natural compound found in certain
Hey,
plants.
can you pause the recording?
Okay.